In this lesson, we're going to look at special factorizations. We have the sum of two squares, which is actually a prime non-factorable. We have the difference of two squares. We have the sum of two cubes and the difference of two cubes. Okay. These factorization methods are an integral part of pre-calculus and calculus. You can see from day one of, for example, calculus, that you are going to have an expression before carrying out the calculus or pre-calculus methods on the problem. You can check the validity of each formula by multiplying the right-hand side to obtain the left-hand side. For instance, for the difference of two squares, we can multiply a times a gives you a squared. We have a times negative b and b times a resulting in negative ab plus ba. They zero out. And then we have b times negative b resulting in negative b squared. You can check the sum of two cubes and the difference of two cubes by performing a distribution of the right-hand side to get what we have on the left-hand side. So let's take you through some examples step by step, showing you what method I use to apply these special formulas. Here we have an expression. As you see, this is called a binomial because there are two terms. And in this binomial, we have a difference and two perfect squares, 25, 36, x squared, y squared, they are perfect squared. So what you need to do is you need to rewrite the problem in the form of something squared minus something squared. Each thing stands for A or B, okay? So here 25, you could say that 25 is the square of 5x. And 36y squared is the square of 6y. Now we can identify 5x with A and 6y with B and plug the result in the parentheses where I have blank spots. Each spot stands for A or B. So we decided that A here is 5x. So you write 5x for A, and then B is 6y. Right? As the formula or the factorization suggests, A plus B, A minus B. Okay, that is the factorization of 25x squared minus 36y squared. Okay, it doesn't matter how difficult the problem might look like. This is what you want to do. You want to identify your A and B. Here is another problem. We have a binomial consisting of a difference of two perfect squared. X to the 4 has degree 4, divisible by 2, meaning that it's a perfect square. 16 is the square of 4. So again, we must write it as A squared minus B squared. X squared is the square of x to the 4 is the square of x squared. So how do I know that? We can use this property. If you have a to the power of n times m, that you could write it as a to the power of n to the power of m. So x to the 4, you could think of that as x to the power of 2 times 2. And that can be written as x squared, okay, to the power of 2. Okay, so the first 2 is the inner power and the second 2 is the outer power. That is how we write x to the 4. And 16, of course, is the square of 4. Okay, so we have our a as x squared and b as 4. Substitute. Okay, a is x squared and b is 4. We get x squared plus 4, x squared minus 4. Now, that's what we get. Look at what you have. We have two products, x squared plus 4. It's a binomial. It's a sum of two squares. And we know already that the sum of two squares is non-factorable, so we can't do anything with that. But x squared minus 4 itself is a difference of two perfect squares. We're going to leave x squared plus 4 alone. And for x squared minus 4, that factorizes to a plus b, a minus b. If a squared is x squared, then a has to be x. So we have x, x. Let's write that actually in green. All right, one with the plus, one with the minus. 4 is the square of 2, so our b is 2. So we get x plus 2, x minus 2. And what we have here is a complete factorization of x to the 4 minus 16. Let's get the next problem. Here we have the difference of two cubes. Obviously, the exponents are 3. So just like the difference of two squares, you need to identify a and b. And then you can plug a and b into the formula. All right. So if u cubed is a cubed, then you can just think of a as u. And 8b cubed, we want to write that as the cube of something. 8 is the cube of 2. And v cubed is the cube of v. And then we're going to apply a and b into the formula for the difference of two cubes. All you have to do is just plug in, and then you're gonna simplify. So we decided that a is u, so wherever I see a, I plug in u. All right, now notice that here for a squared, I wrote parentheses squared. Here parentheses stands for a. It's a placeholder for a. We have another a right there, which is our u. And b is 2v, so everywhere you see a b, you're gonna write 2v. But we're not done yet. The last step is to simplify. Inside the first parentheses, we have u minus 2v. There is nothing we can do with that. But we have here the square of u. Well, you can just write that as u squared. And after the plus sign, we have the product of two factors. U times 2v is 2uv. Okay, remember that the order of multiplication doesn't matter. U times 2v, you can write that as v times u times 2. In this case, we prefer to write the coefficient 2 first. And then lastly, we have the square of 2v, which is 4v squared. And that is it with this problem. This is the factorization of u cubed minus 8v cubed. Okay. Our next problem involves the sum of two things. We have again a binomial, right? The hardest part of the problem is to identify what kind of expression you're dealing with. Okay, so again, there is a sum here, meaning that we are not dealing with the difference of two squares. Notice that 27 x cubed, 64, these are all perfect cubes. Z to the 9 is a perfect cube because its exponent is divisible by 3. Y to the 6 is perfect cube because its exponent is divisible by 3. So once again, you need to rewrite this expression as the cube of something plus the cube of something else. 27x cubed is the cube of 3x. 64, so here for the second binomial, let's just take it factor by factor. 64 is the cube of 4. Z to the 9 is the cube of z cubed. And again, that's true by this formula. Just check it out. Z cubed. You multiply the exponent as we have multiplied the exponent. That would give you z to the power of 9. And then we have y to the 6, which is the cube of y squared. Here, it seems like I don't have enough room. So we have identified A and B. You're gonna refer to your formula, and anytime you see an A, you're gonna replace that with 3x. Okay, so 3x. There we have 3x and 3x inside the bigger parentheses. Our B is 4z cubed y squared. Okay, so anytime you see a B, you're going to replace that with 4z cubed y squared. All right, this is the hard part. Next step is to simplify. And by that, I mean that we have to exponentiate, we have to multiply, and we have to exponentiate or square here to get to the final expression. All right, so inside the first parentheses, we have basically 3x plus 4z cubed y squared. There's nothing we can do with that. Then we have the square of 3x. The square of 3 is 9, and the square of x is x squared. For the next term, we have to multiply these out. You can begin by multiplying the constant factors. They would be 3 and 4. Multiply those first, you get 12. Okay? And then we have the remaining factor that are x, z cubed, y squared. Notice that one mistake, which is common among some people, is that they distribute 3 into every factor. And that is incorrect. We are not looking at the product of a factor and a sum. People are thinking of A times B plus C. B plus C consists of 2 terms. Then you have to distribute A in. But here we don't have terms. We don't have a plus. So you can't distribute a factor by other factors. Okay, you just multiply the coefficients. If you were to distribute 3 by every factor, then you're going to have 2 extra 3s, which is not the case here. And then lastly, we're going to square 4z cubed y squared. The square of 4 is 16. The square of z cubed is z to the power of 6. And again, that's by this property. And the square of y squared, multiply the exponents. You get y to the power of 4. And here you have the factorization of 27x cubed plus 64 z to the 9 y to the 6. Looks like a pretty complicated problem, but again, you can, as long as you can identify your A and B by rewriting the problem as the sum of 2 cubes. So just write the sum, 2 parentheses, cube each parentheses, and then see what should go inside each parentheses, right? To get or to identify A and B. I hope this lesson was helpful. And again, I can't emphasize enough how important these formulas are. You're going to use them extensively in pre-calculus and calculus.